Hello students, myself Dr. Divya Ghildiyal in continuation with my lecture series on AKTU Energy Science and Engineering for BTech second year students. Today I will be briefing you Unit 4 of your syllabus, Conventional and Non-Conventional Energy Sources. Please subscribe to my channel in order to receive a fully solved model paper 5 days before your final exam. Thank you. Let us now see what is the syllabus for your Unit 4. Conventional and non-conventional energy sources. This is a theoretical paper with 10-mark questions coming in section C, where you have to write a lot. So in order, this unit is 1/4 of your general knowledge and events happening in day-to-day life. It is not a mathematical paper and not a paper where you can be just told that you have to learn this much and write. It is more related to the current events and what is happening in the field of energy sources. So let us begin. Conventional and non-conventional energy sources. That means the commercial ones, which you are like coal, etc. The non-commercial ones like the firewood, etc., solar, wind energy, tidal energy, etc. Biological energy sources obtained through, you can say, nature or biology. Fossil fuels, that means which we get through the dead or the organic decay matter. Fluid dynamics, fluid is water. Bernoulli's principle of energy conservation. Fluid, how water, when it creates a pressure difference, also results in energy. Power in the wind turbines, when their blades rotate, it helps in the generation of electricity. Water or the fluid having property of viscosity, and also the type of fluids, streamline, turbulent, etc. Wind turbines, how they help in the generation of electricity. Wind farms, where large number of wind turbines are there. Geothermal, geo is geography or something related to below the earth heat, how that has been used in the generation of electricity. Hot water springs. Ocean, the tides, the waves that are formed, and ocean, how the pressure difference has been used in creating energy. Tidal energy, the wave, ocean wave energy, when the waves movement goes up and down. Hydropower, water falling from a specific height, also results in energy. What has been asked in this unit is this question: write a short note on conventional and non-conventional sources of energy. 10-mark question. What do you mean by biological energy sources? Again, a 10-mark question. Why is fluid dynamics so complicated? 10-mark question. Discuss in detail wind turbines has been asked, and comparison between geothermal and ocean thermal energy has been asked. Tidal wave hydropower, one question has been asked in your previous year question papers. Okay, now let us begin with the syllabus. The more drop down diagrams you are going to make, the more tables you will make while explaining your answer, the more marks you are going to fetch in this theoretical paper, because nothing is predefined or 100% definition. Many things which you are studying in this paper are under research. Okay, now try to see if this question comes that discuss in detail conventional and non-conventional energy sources or their classification. Try making this diagram. I will explain it to you. Conventional sources of energy and the non-conventional. We have divided the sources of energy into two major groups. Now, the conventional ones, more like you can say the traditional energy sources, or the non-renewable ones, like once you have used them, they are over. Like coal, you burn coal, you are left with ashes. Petrol, you have used petrol to run your car or two-wheeler, it is off. Again, you have to get your petrol refilled. Electricity you are using in your house, the more you are using, the more it is getting consumed and it's over. The non-conventional sources are the ones which we are more dependent on nature. They are pollution free and a cause of clean environment, because here energy is got through it without any wastage. Solar energy, unit 3, please check my playlist of unit 3 solar energy. I have explained you solar energy in detail. Wind turbines, windmills, wind farms. When the wind rotates the blades of these turbines and farms, it generates electricity. Tidal, that is the waves, when the wave movement goes up and down, tides. And energy from urban waste. So this is how I have broadly classified my energy sources. That means those that are exhausted after use are known as the conventional or non-renewable energy sources, like coal, gas, petrol, etc. Natural sources like wind, tides, solar, etc., which are pollution free and a very good cause for clean environment, are the non-conventional ones. Biological energy is energy which is produced from organic matter, which has been derived. You can even use it from the dead plant and animals, like biofuels for transportation, sawmill powered by wood waste, sustainable renewable energy. A short try making this diagram in your answer. I will give you a shortcut for this diagram. You can say types of biomass energy. Write 2-3 short lines here in this diagram only while explaining your 10-mark answer. Bioenergy is one of the many diverse resources available to help meet our demand for energy. It is a form of renewable energy that has been derived from recently living organic matter materials known as biomass here, which can be used to produce transportation, fuel, heat, electricity, etc. Like I have made wood in this diagram. Wood is used to create energy. People in villages and forests, they burn wood to cook their food. They burn wood to reheat their food for cooking, etc. Then crops can also be used for the same purpose. Alcohol fuels can be used also for lighting their lamps at home, and for getting light at their place at night. So these are all types of bioenergy. So bioenergy refers to electricity and gas that is generated from organic matter. Now, biological energy sources are the solar energy, which is defined as transformation of energy that is present in the sun. And obviously, sun is the major cause of all approximately all energy phenomena. Once you can again refer to Unit 3 playlist and get a detailed description of solar energy. You can also write that here. In short, I'm just discussing this because it is in the syllabus, again has been repeated as a heading. Advantages of solar energy are, obviously it is clean, one of the cleanest form. During COVID times, all COVID patients were told to take sunlight so that it kills the viruses, and office space buildings have been strictly told to be designed in such a manner that they get maximum sunlight during daytime. Renewable, that is ample amount of energy available on earth. As long as the sun is existing, life is there. Reliable, that means we totally trust the sunlight energy, and it results in utility cost reduction. Biggest disadvantage of solar energy is that it is nature dependent. That means on a cloudy day, on a day where a lot of pollution is there in the environment or the atmosphere, then what happens is we are not able to utilize solar energy in full strength. Wind energy, wind. Have you seen wind turbines near especially ocean places or open large places where lot of wind is flowing? That wind energy is used to generate electricity. It is used to run the turbines, and then that mechanical power is converted to electrical power. That means it describes the process by which wind is used to generate electricity. Wind turbines convert kinetic energy in the wind into mechanical power. A generator can convert mechanical energy in power into electricity. Geothermal, that means from earth. Whatever we are taking from earth, the type of energy, using it to run my turbine and generate electricity. Fossil, all fossil fuels in existence have been produced over a long period of time. They're from plants, animals that have died many years ago. Slow transformation of this carbon heavy material into various combinations of hydrocarbons have resulted in the creation of highly flammable fuels like petrol, coal, natural gas. And if you are a bit aware of current studies, etc., you must be having an idea that these are depleting fast in nature. So it is high time that alternative sources are thought of for replacing the fossil fuels. Okay. Petroleum, what is petrol? It is clear, oily liquid and black in color. It is also termed as black gold because airports, cars, motorcycles, power backup, etc., they all are requiring petrol. You can give in many uses of petrol, like give examples which you are using in your day-to-day life. Like suppose you are driving a two-wheeler to office, write that as an example. You are using petrol for any other work, try including that in your answer. Coal, it is a hard black colored substance made up of carbon, hydrogen, nitrogen, oxygen, and sulfur. And coal is used a lot in cooking purposes in villages, etc. And the process of coal is known as coalification. The dense forest present in the low-lying wetland got buried in earth millions of years ago. Soil kept depositing over them. They got compressed, and when they went deeper and deeper, they faced high temperature and pressure, as a result of which they got slowly converted into coal. Coal, major use is in railway engine running, all the trains which are dependent on coal. In the mid times, many types of new trains came up based on magnetic technology, based on other technologies, but still 3/4 are using coal. It is used to cook food. It is used to generate electricity in thermal plants. Natural gas, it is clean and non-toxic fossil fuel. Colorless, odorless, it is stored as compressed natural gas, or short you say CNG, under high pressure. Natural gas also has a long way of getting formed. It is compressed natural gas used in fuels, automobiles, homes for cooking. Wherever you are asked applications, you think in mind all the applications of energy utilization, and you can mention them easily. If the 10-mark question is asking you to write the merits or demerits. Okay, fluid. The question asked in your paper, and it was a 10-mark question. Why is fluid dynamics so hard? Now, listen carefully. See, fluid dynamics directly, we cannot say that it results in the generation of electricity or power or energy. Bit of mathematical concepts and physics concepts are required in understanding how fluid can also be used as an energy generation. But fluids are of many types. That is what the question is asking you. Fluid dynamics so hard. Their resistivities are different. Their viscosities are different. Like water is a fluid, petrol is a fluid, but both have different properties. So though they both come under the category of fluid, their viscosity is different, their color is different, their density is different, their properties are different. So it becomes very complicated to apply fluid dynamics when we are choosing is as an alternative for my energy studies. So fluid dynamics is hard. The main reason being that there are more exceptions here than I can just say a straightaway rule. That coal, suppose, is very easy. Burn coal, cook your food, iron your clothes, or use it for running the engine. But you cannot just do that directly with fluid dynamics. Certain fluids are like, if I drop one sodium drop in water, it becomes flammable. It is very dangerous. So we have to take the decision very carefully. This subject evolves from observing behavior of fluids and then trying to put them in the context of mathematical formulation. Here, I will make you do one derivation of pressure difference. I will make you understand Bernoulli's principle and how this pressure difference can also be used for generating energy. Plus, fluid dynamics is a very good research field in current scenario. Fluid mechanics helps us understand the behavior of fluid under various forces and at different atmospheric conditions. You must have heard that don't keep your petrol tank full when it is very hot outside. Keep certain level of space left in the petrol tank, because heating results in gaseous formations itself in the petrol, and it can be dangerous. So there are many precautions which have to be taken when we are choosing fluid dynamics as our source of energy. Now, the different types of fluids flows are steady, unsteady, uniform, non-uniform, laminar, turbulent, compressible like mercury, incompressible, rotational, irrotational, 1, 2, and 3 dimensional flow. The basic fluid mechanic principles are the continuity equation, that is the conservation of mass, and the momentum principle or conservation of momentum, and the energy equation given by Bernoulli's theorem. Note that fluid dynamics is changing our world. It is going more and more in the research field, but the concepts have been lifted from physics. Bernoulli's theorem, conservation of mass, momentum principle. Fluid is affecting our daily lives, and the best part of choosing fluid is that it is comprising 70% of the earth. So it makes us understand many more phenomena. So fluid is a substance that can flow continuously and keep changing shape, etc., according to whichever vessel it is poured in. So there are, of course, major differences if I pick up a fluid or a gas. And I know from physics that the force acting on a fluid is specified by the formula pressure is equal to force upon area. Pressure is a scalar quantity. So before I start understanding fluid dynamics, I need to understand certain properties of the fluid. First, most common property is viscosity. That means the resisting property. Ability to flow means that all liquids are having the property of fluidity. These properties are typically a function of their inability to support any type of shear stress and static equilibrium. The fluid shear stress is a function of strain rate. Okay, the wind energy is a renewable source of energy that determines the total power in the wind. The wind turbines convert kinetic energy because the wind turbines are moving with velocity v, so half mv square. This is getting converted to mechanical power, wherein the mechanical power is converted to electricity. So wind energy gets converted to mechanical energy gets converted to electricity. Wind energy formula is given by P, that is the power, is equal to half rho, that is air density, A, area swept by the blades of the wind turbine, and B, the velocity of the wind. Numerical has been asked on this formula. Determine the power in the wind if the wind speed is 20 meter per second and blade length is 50 meter. Given air density is 1.23 kg per meter. So wind speed, meter cubed, air density, mass upon volume. Wind speed V is equal to 20 meter per second, blade length 50 centimeter, air density 1.23. Area pi r square. Here r I will keep as 50 yes, 50 meters it has been given. So r square becomes 50 into 50, 2500. So area is this. Putting this value of area in my formula, putting the value of rho that has been given to me and putting the value of V, which is given to me in my numerical, I can find the answer. Wind energy is the kinetic energy of the moving air. So kinetic energy, do this formula along with me, is given by half mv square. The air mass can be determined from the air density rho and air volume v accordingly as mass is volume into density. So I put this expression of mass in my equation above here. So it becomes E is equal to half V rho this mass. Instead of mass, I'm putting density into volume. And power is energy divided by time. So we consider a small time t in which the air particle travels a distance s, which is distance is speed into time to flow through. We multiply the distance with the rotor area of the wind turbine, capital A. So I get del V is equal to AV into del T, which drives the wind turbine for a small period of time T. Now power of wind is E upon del T. E I have derived here above, half V rho V square. I put this value and I get rho A V cube upon 2. So the power increases with the cube of wind speed, as you can see. And there is a variation when this speed is flowing. pressure difference is created because of this. So the effective pressure difference can be found by subtracting for P1 you keep it where it is entering and P2 you keep where it is exiting. So it becomes P1 minus P2 is equal to rho A upon 4 into V1 plus V2 into V1 square minus V2 square. If the difference of both the speeds is 0, there is no net efficiency. If the difference is too big, the airflow through the rotor is hindered too much. And for maximum power, let us take one power coefficient relative to drawing the power, and let V2 upon V1 be taken as X. Just we are doing all this to write this formula in a more simple form. That is all, not doing any derivation. And then we put P effective upon P wind is equal to 1 plus X into 1 minus X square by 2, where X is V2 upon V1. We differentiate this value, and using the formula d by dx of x to the power of n is equal to nx to the power of n minus 1, we get x is equal to 1 upon 3. We put this value of 1 upon 3 in this expression above and we solve. We get the ideal power coefficient is approximately 59%. Thank you.